I don't.
Okay, I'll get started. So,
I gave you everything, so I guess.
Eliminated Graham does these introductions so well. I'm gonna try to emulate this, but it's, welcome to the Integrated Environmental Health Sciences Seminar Series, held for the Center for Leadership in Environmental Awareness and Research, and Center for Urban Responses to Environmental Stressors. So it's a tremendous honor to introduce Dr. Alan Wilcox, an epidemiologist and emeritus investigator at the National Institute of Environmental Health Sciences, whose work addresses infertility, pregnancy loss, fetal growth restriction, birth defects, and neurologic disabilities. Dr. Wilcox holds an MD from University of Michigan, an MPH and PhD from in epidemiology from the University of North Carolina, and an honorary doctoral degree from the University of Bergen. He spent his career at NIEHS in Durham, North Carolina, with adjunct professorships at UNC and Harvard and the University of Bergen in Norway. He was editor-in-chief of the journal Epidemiology for 14 years, served as the president for the Society for Epidemiologic Research and the American Epidemiological Society. And since his retirement in 2019, he's continued research collaborations in the US, Canada, UK, and Scandinavia. So Dr. Wilcox authored 2 books, notably including the seminal textbook Fertility and Pregnancy, an Epidemiologic Perspective, published by Oxford University Press as a new edition out this year, I guess. And he has published more than 400 research articles, many of which are highly cited, lead more than 23,000 citations from Web of Science. And his work is the basis for phone apps used by more than 40 million women to monitor their fertility. I especially admire his work on the paradoxes of birth weight standardization, gestational age adjustment, and a bunch of very innovative and creative thinking. So much more. His contributions have earned numerous honors, including the Kenneth Rothman Career Achievement Award, NIH Distinguished Service Medal, but also SPER's Mentor of the Year Award, just to name a few. So please join me in welcoming Dr. Alan Wilcox, who will speak to us today about the study of fetal growth restriction. Thank you so much, Alan.
Thank you, Stephen. And thanks to the Center for inviting me. There are 2 good reasons why I'm glad to be here, especially. One is that my grandparents were immigrants who came to Detroit to work in the factories. I grew up in Southfield. I was accepted to medical school at Wayne, and I might actually have come here, except my girlfriend went to that other medical school in Edinburgh. It turned out okay. We've been married for 55 years, so it wasn't a bad move. The other reason I'm glad to be here is that although my talk is simple, the problem I'm laying out is not simple, and the solution to it is not simple. And I think the solutions are going to come from people in this audience. So I'm especially grateful to have you here and to be able to present what I see as a really interesting challenge. So let me just make sure all my things are working here. This talk that I'm giving is based on a paper that has been published. So if there's something that you are interested in hearing in more detail, you can look up this paper. And I might also add that if there's anything that I'm saying along the way that is not clear or is confusing, I'd much rather have you interrupt and ask me to clarify than to have you wonder what I'm talking about. So I don't mind interruptions at all. And for those of you who are watching remotely, there is an opportunity for you to put questions into chat, and there will be time at the end. I'm planning at least for asking questions and discussing this. So I'm going to start with fetal growth restriction, which is a clinical entity characterized by fetal wasting and placental pathology, often with preeclampsia. There are many possible underlying pathologies. Affected babies, I mean, this is a crucial thing. They have a high risk of mortality and morbidity, high relative risk. And here's the catch. We don't have any way to define it. There is no gold standard marker for fetal growth restriction, even though when it's an extreme case like this, we can say, like in the picture here, we can say this baby is definitely affected. But how do we identify this condition conclusively in one baby and not another? We don't have a way to do that. And so without a clinical definition, we rely on birth weight as a surrogate marker, and specifically being small for gestational age, which is just to say small size given the length of pregnancy that baby is at. So SGA has a lot of great advantages. Very easy to measure. It only takes data on birth weight and gestational age, both of which are on birth certificates. We have the data for millions of babies, and it's associated with increased mortality and morbidity. So it's easy to study. And this is just some of the underlying data to say why SGA has been a successful marker. On the x-axis, it's the percentile birth weights by gestational age. And on the y-axis is neonatal mortality. And you can see that the risk of neonatal death is 20-fold higher among the smallest 1% of babies. The 20-fold risk in epidemiology is like, off the charts. We're happy if we can find a 3-fold risk, and this is enormous. So this is important in some way. And SGA's standard definition is 10th percentile, but there's nothing standard in this area. People use a lot of different definitions. If you go to 5th percentile, then you're capturing, an even higher risk group. And there are, a number of studies that will use 2 standard deviations or 2.5 percentiles, which really captures the extreme small group of high-risk babies. So my exploration of this began when I asked this question: what percentile is the best one? And it occurred to me that receiver operating curves really were ideal for making this determination. So as I'm sure most of you know, I need to remind myself about this every time on the rare occasions when I actually do receiver operating curve analyses. It's a way to find an optimum cut point for a continuous predictor of a dichotomous outcome. So birth weight percentiles, perfect continuous predictor. Neonatal mortality is a good example of a dichotomous outcome. And so I thought if we do an ROC analysis and I come up with a definition of SGA that's like, it's the 6th percentile that is optimally identifying the high-risk babies, I'll be famous. Everybody will use this. Great contribution. So just to remind you what these analyses look like, it plots the sensitivity against 1 minus specificity actually on the x-axis. And if that plot of the continuous variable as a predictor looks like this, it means that it's totally worthless. It's no better than flipping a coin to decide if your baby is in one category or the other. So that's sort of the extreme low value. And then we have various areas under the curve, under the receiver operating curve. And they're usually categorized like this, which is conveniently the way, school grades are often done, where 90 to 100% would be great. 70, 80 is pretty good. Anything under 60 is like, you're gonna have to repeat that grade. And the other thing that the ROC provides is this thing called the Yoden point, which is the specific point on the curve that maximizes sensitivity and specificity, the combination of the two. And so that's really the point I was going for on this on this SGA exploration. What is the point that optimizes the prediction? So is it going to be 10th percentile, something lower, something higher? Well, I started with the US vital statistics data, really simple, large data set. And this is what I saw. The area under the curve was 60%. I couldn't believe it. I thought something must be wrong. Maybe, the US data come from various states that have various definitions of live birth, and maybe it's just crummy data. So I went to my Norwegian colleagues and I said, you've got these great birth registries. Can we do this analysis using Norwegian data? So my colleagues gracefully assented to that, and we did the same analysis with Norway data, and it was almost precisely the same. So something I forgot to do when I was putting these slides together was to show the same curves with gestational age. And given that many of you have an obstetric affiliation, I thought you might find this interesting. I don't have the slide, but I'll tell you what we found. I thought, well, maybe there's something about neonatal mortality that just isn't very predictive. So let me try how well gestational age predicts neonatal mortality and what that receiver operating curve looks like. The area under the curve was 88%. Phenomenally different than this. Gestational age is a really good predictor. And the clincher is that the Yoden point, the gestational age that best discriminates neonatal death from survival, is less than 37 weeks, which kind of blows my mind because obstetrics has been using that for a century, and they certainly didn't establish it by doing ROC curves, but somehow, and it's even longer than that, it was late 1800s, at least, when 37 weeks was being used as a criterion for preterm delivery. So clinical intuition sometimes is really good. So for getting back to birth weight percentiles, there's no good cut point. So that's a problem. So these results for birth weights, and I thought, well, what about ultrasound measures of fetal size as a predictor of mortality? So now we're talking about not just neonatal mortality, but including stillbirths. And it happens there was a paper that came from your department. This is one out of Roberto Romero's research group predicting adverse perinatal outcomes by various customized and population-based standards for fetal growth. And they found that most of these areas under the curve were less than, actually they were all less than 70%. That 170% there is a rounded up. So they're all in the category of poor. So fetal size is really not much better than birth weight in predicting outcomes. So if size is not a good predictor of mortality, might it still be useful for studying fetal growth restriction? Well, let's think about that. First of all, we know that fetal growth restriction and small size are not the same thing. Surely they overlap, but it's very clear, the clinicians have been clear about this at least, that babies can be SGA and still be healthy. They're just small. Maybe their mothers are small, they're constitutionally small, and they do not have any increased risk compared to larger babies. So this is a crucial piece of the puzzle because what it says is that SGA is not actually a cause of poor outcome. It's associated with poor outcomes because there's some variable, which I'm going to call fetal growth restriction here, that causes small size and causes high mortality and morbidity. So in epidemiologic language, this is a confounder. And in our case, it's an unmeasured confounder because we don't have any way to define fetal growth restriction that's independent of size. But we're pretty sure that this picture is correct. that there are some small babies that are not growth restricted. And there are some babies that are not small, but are still growth restricted. And you can picture this easily. If a baby is destined to be 9 pounds and it's born at 7 pounds, you know, a substantial restriction in its growth, it could be average at birth and still suffer all the effects of being growth restricted. So that creates all kind of interesting problems when we use SGA. The clinicians are pretty clear about this. Epidemiologists, we've mostly ignored this because it's so inconvenient for what we want to do. So let me point out 2 false conclusions that we come to when we define fetal growth restriction as being SGA. One is the prevalence of fetal growth restriction, and the other is the risk of mortality and morbidity. I mean, these are not trivial features of this pathologic character, it is sort of fundamental. So, prevalence. You will often see review papers that say fetal growth restriction is an important public health problem because it affects 10% of all babies. Well, duh. If you define FGR as the 10th percentile of birth weight, then it's always going to be 10%. As one of my colleagues pointed out, we could reduce fetal growth restriction by half just by changing our definition of SGA to 5%. So without an independent definition of fetal growth restriction, we do not know its prevalence. Let's be honest about this. Maybe it's close to 10% as when we define it by SGA as 10%, but maybe it's much less, or maybe it's much more. How do we know? We don't. So the other path that we're led down that is misleading is the statement that fetal growth restricted babies have a 3-fold risk of neonatal mortality. That's pretty consistent across populations. You see a lot of papers that report this. And of course, that's not necessarily true. What we can say is that SGA babies divided by the 10th percentile have a 3-fold neonatal risk. But let's go back to that other figure of overlapping Venn diagram. If most SGA babies are healthy and the mortality of SGA is 3-fold due to some component of SGA that is FGR, then the actual mortality of the FGR babies must be something greater than 3-fold, and maybe substantially greater. Does that make sense? So another problem with SGA is what we, in the epidemiology language, call the counterfactual. The counterfactual is sort of the conceptually what we would see if we could totally prevent the disease we're interested in. And so what would the birth weight distribution look like if we could prevent SGA? Well, the birth weight distribution, these are term births, really elegant Gaussian distribution. We define SGA as the smallest 10th percentile. Do we really think that if we prevented SGA, it would look like this? Can't happen. That's not biology. And there's no population in the world that has a birth weight distribution that looks like that. It's a much more plausible counterfactual to say, if we could prevent all, what does the distribution of fetal growth restriction look like under the biological definition of a failure to achieve its target weight? That's sort of the conceptual idea of fetal growth restriction. And it makes sense that what the FGR distribution would look like is something like this, shifted to the lower weights, but still Gaussian, still some babies who are relatively heavy within that distribution. And SGA doesn't capture all of those. This is just, a made-up example of what we think would happen. And I'll show you some actual data in a minute that look a lot like this. So I'm providing this label. I can email this to anybody who wants it. This is something to apply to any paper that you have at home that uses SGA to define FGR, and sticker that says using SGA produces misleading information. Don't trust it. So is SGA useless? No, it's not useless. It's still a valid marker of a group of babies who are at increased risk. We just can't interpret it as a measure of fetal growth restriction. Fetal growth restriction is something else. It has a prevalence we don't identify. It has a mortality risk, which we can't measure. So if it's not SGA that's going to lead us to the right answer, what is the right way? That's why I'm here. I want you to tell me. We need definitions of fetal growth restriction that are not based on size. So now I'm going to describe a paper that's done by some Canadians, as a matter of fact. Jennifer Hutchin is a excellent reproductive epidemiologist and methodologist. And she did this analysis using latent class analysis, which is it's a little bit of a magic trick, I have to admit. It's something that has been used a lot in infectious disease. The idea is to identify some condition for which you don't have a perfect diagnostic test, but instead you use a lot of imperfect tests to try and converge on a group of people who have the condition you're inferring they have the condition that you're interested in. And so Jennifer used a very unusual data set that was available in Canada, where a lot of intensive measurements had been taken through pregnancy for, now I'm forgetting how many it was, 8,000, 12,000, something like that. And so she had data on maternal comorbidities, with placental anatomic features that were visible on delivery, placental weight, metabolic acidosis in the fetus. And what she came to was looking only at term births to kind of get the preterm picture out of the way, because those are confounded by other problems. If we just look at the 95% of births that are term, she calculated that about 1% of them had fetal growth restriction. And they experienced an extreme downward shift in their birth weight, 1.6 standard deviations. So that's about, maybe 700, 800 gram smaller than expected. And that's, compared to anything else that we know about, smoking decreases birth weight by 150 grams. Other exposures that we have are all in the, in the range of 100 to 250 grams. So a 700 gram reduction in birth weight is huge. There's nothing else like it that we know. And here's the picture. This is Jennifer's data on the distribution of the babies identified as being fetally growth restricted. And you can see it's just what we would expect. It's a shift of the whole distribution downwards. And this is all on a frequency distribution scale. So it doesn't really show you visually that there are only 1.3% of the babies in the fetal growth restricted group and 98.7% of the babies in the unaffected. But what you can see here is that SGA captures just about half of these kids. And the other half, some of them have birth weights even up close to the mean for the unaffected, but they're still in this very high risk group. So there are now 3 or 4 studies, all with very different methodologies, all epidemiology, that have tried to get at definitions of fetal growth restriction that are not based on entirely on birth weight. And These are all studies sort of in the aggregate. They're not identifying individual babies that have this condition. It's more identifying the proportion of babies who are affected. And these are all, any one of these studies you could look at and say, well, that's kind of a, an odd way to go around about studying something that we can't measure. But the really interesting thing is they're all converging on the same result. And these papers are cited in the reference that I mentioned earlier, if you actually wanted to dig into these. In all of these studies, fetal growth restriction seems to be occurring in about 1% of term births. And the observed mortality of these kids in relative risk terms is extremely high, more than 100. In fact, in one analysis, the relative risk was 200 times higher. That in absolute terms is still not, it doesn't mean it's a fatal condition. In the US data, in the most recent time period that we've analyzed, the absolute risk of death was 4%, but 4% was 160 times higher than the baseline mortality for that population. So we've got a rare, severe condition that we don't have a good definition for, but this does help explain why birth weight percentiles are so poor in predicting outcome. It's because only about 5% of that 10% of SGA are really fetally growth restricted. So SGA is a very insensitive way to capture FGR. And it's also non-specific because the babies who are not SGA, there's a number of them who still have fetal growth restriction. So we've got SGA as insensitive and non-specific marker. It leads us to the wrong answers. So where do we go from here? This is where epidemiologists on our own run out of steam, because what we need are clinical markers. We need a way to define this condition that isn't something that we're going to easily find on a birth certificate. So fortunately, this is a pretty active area of research in some ways, because clinicians are really interested in predicting preeclampsia, finding early markers for preeclampsia. And those early markers for preeclampsia are identifying, some dysfunction in placental physiology that may also be associated with fetal growth restriction. So I'm really hopeful that out of this recent flurry of research on early signs of preeclampsia, some things might emerge that will turn out to be good markers of fetal growth restriction. It could be biochemical, could be imaging. We know that Doppler measures of blood flow are pretty effective in predicting certain infant outcomes. It could lie in the pathology of the placenta and other things that we haven't even thought about yet. So the clinicians are interested in this because they want to identify these fetuses early, that they might be able to intervene and effectively treat the babies. One other thing I didn't say about these indirect studies looking at fetal growth restriction is that it appears that the condition arises very early in pregnancy. So there's been a lot of clinical literature over the recent decades focusing on slowing of fetal growth in the third trimester as a marker of fetal growth restriction. But the emerging data seems to be pretty clear that if you look at small babies at birth who were small from the very beginning, the earliest ultrasounds, and compare their outcomes with the babies who had this slowdown in the third trimester, it's the babies who were small early on who are really at high risk. This is not to say that slowing down is necessarily harmless later in pregnancy, but that this condition of fetal growth restriction seems to be one that has its origins in the earliest stages of development.
Excuse me, You did lose me on that one. So you meant fetuses that were slowing down earlier, right?
Yes, I'm sorry, what did I say?
Babies.
Babies, yeah, let's talk
Okay.
about fetus before they're born.
We're doing correlation to later event or the actual, in that
Yeah.
second trimester or
First trimester.
first trimester?
Yeah. I mean, most of the US ultrasounds are whatever.
Crown to rump or that kind of measurement?
Say again?
Crown to rump?
Yeah, right. But they're done, like 16, 17 weeks. There's some European countries where they do them at 12 weeks. And of course, the dating ultrasounds are done even earlier than that sometimes. So it gets tricky about what ultrasound measures you want to use.
So which week in first trimester, in 6, 7, 8, I don't know exactly when crown to rump.
So, you all tell me, when are the dating done?
I think it's around 10.
Around
10?
10?
So pretty close to the end.
Yeah, right. Okay. So, right, so the early ultrasounds may provide us some really interesting information about growth as well as dating. So epidemiologists need these clinical markers in order to be able to study the things we're really interested in about fetal growth restriction, which are its prevalence, its risks, the things that might cause it. And, to do this, we need large samples of pregnancies with clinical data, which is hard to come by. It's much easier to use vital statistics data than it is to find good clinical data collected throughout pregnancy. So it's possible to do prospective studies. Epidemiologists want thousands, clinicians, are not really into cohorts of thousands, but some Europeans have suggested maybe we could start pooling these prospective studies, these clinical studies, to come up with larger sample size. There's also the opportunity in some countries, and my colleagues in Sweden have been doing this on a limited basis, of combining electronic medical records as collected in they actually have a medical health system like us, where on a population level, they can consistently have certain measurements during pregnancy linked to the pregnancy outcome registries, which are potentially quite important with the goal of discovering what actually causes this condition. So what we don't need is more papers making conclusions about fetal growth restriction based only on SGA. So I did a PubMed search for papers that had both small for gestational age and fetal growth restriction in their keywords. And this is what the publications look like over time. It's rapidly accelerating. These are so easy such easy papers to write. We're getting more than one paper a day now. And when I present these arguments to my colleagues, saying SGA, it's not telling us what we want to know. These are the kind of comments I get. Well, the data are so easy to get. It's true. I agree. They're easy to get. And then they'll say, well, the studies are publishable. We can get these published in journals. And I'll say, yeah, that's right. They're publishable. Okay, it's not a perfect marker, but it's the best we have. I mean, we often have to rely on imperfect measures. Well, it may be the best we have, but it still stinks. It's still not working for us. And then this is what we usually come to. Surely you're not saying we should stop all SGA studies, fetal growth restriction. And yeah, that's exactly what we're saying. So I think of it like this. The study of SGA is like having a high-powered sports car going down this paved highway where you can, it's like the Autobahn in Germany. You can drive any speed you want to, and it feels great. And unfortunately, it's not taking us where we want to go. Fetal growth restriction is still an obscure condition, although we know it's real. It's at the end of some winding road that we haven't even done much to explore. So the bottom line is that studying SGA is easy. Studying FGR is hard, but only one of these is going to get us where we want to go. So I'm going to stop here and I'm going to be really interested in your comments. Thank you.
That was a great presentation. Thank you so much. I happen to be an engineer and I'm one of the co-directors of the CLEAR Center. So my counterpart is more of a med person and I'm more engineering, environmental science, but you presented this so well. It made a lot of sense to me and it was really clear. And as an engineer, I loved all your Gaussian curves. I loved all your conceptual expressions. I really enjoyed it. But since I am an engineer, there are a few things I didn't understand, which I'd like you to explain.
I was waiting for that, but.
Okay, so one thing that's is confusing to me is that you make the statement early on, and you kind of show this all along, that FGR it's really elusive. We don't have a definitive way to say whether this baby or this fetus is undergoing FGR as opposed to SGA. And so many people take the easy route and just use both together. But then at the very end of the presentation, you said something about, well, some of your colleagues suggest maybe just keep driving with SGA because it's easy, we know how to do it. But you said, but we shouldn't forget FGR because we know it is real. So then it made me think, how do you know it's real? How do you know it's real if you can't, you said that the metrics or the way to define it isn't clear.
So I would actually be interested if there's anybody in the room who is a clinician who's seen these babies. Because, you know, even though I have a very rusty MD, I've never, none of the babies I ever delivered had this condition. So I'm relying on the clinical literature to say there are these babies who seem to have this cluster, this syndrome that I described. But I think your question is one we ought to continually be asking ourselves. If this is real, then there must be a way to identify it. And if we can't identify it, is it real?
You're suggesting that clinically, by observation, once the birth occurs, the clinician can make a determination that this baby is FGR as opposed to SGA. So the clinician can do that.
I think in extreme cases, yes. When there's an extreme case of fetal growth restriction, the baby is very emaciated, muscle wasting, you know, having a lot of problems after delivery, that would get labeled as fetal growth restriction. And does that happen to babies who are not SGA? It does. You know, that's reported in the literature. Are there small babies who don't have those problems? There are. You know, one of my grandchildren included. So, but you know, but it's different to say, I know it when I see it in an extreme case, but how do I define it to cleanly differentiate one group and the other?
Thank you.
I'm not an engineer, but I am going to back my learned colleague here and ask the question, is this not perhaps just an example of scientific culture tilting for a windmill that people think must be there, but isn't necessarily worth finding on its own terms as FGR? What is the outcome that the clinician sees and can write down, that if we then throw it in a machine learning program, gives us the emergent properties that defines something that you might agree is FGR, but I still come back to, I'm not sure. If you said our goal is to eliminate people talking about FGR in the literature, I would be behind you 100% as an editor, 100%. If you can't define it, if you can't tell me what the outcome is that says this is FGR, stop talking about it.
No, I hear you. And the thing that keeps me from kind of retreating to that more nihilistic conclusion is the high risk with very, very low birth weights. I showed a 20-fold relative risk for small babies. We know that birth weight is not causal. There's some confounding variable that's causing that high risk. If you go to, instead of the smallest 1%, you go to the smallest 0.1%, the relative risk is 500 times. There is something that is affecting babies that's much more prevalent in small babies than in large babies that's causing a huge risk. And so I have to believe that there's something there. It has to be something. And
I won't change my position on nihilistic is my middle name.
That's right. And I think that voice needs to be at the table, but it's not enough to persuade me that there's nothing going on. There's some confounding variable, some unmeasured thing. We're calling it fetal growth restriction. That's associated with small weights, and it is causing, according to our calculations, half of all neonatal mortality in term babies. That's an epidemiologic estimate, not based on a definition of fetal growth restriction, but based on the increased risk among small babies, which is not causally related by birth weight. It's caused by whatever the confounding variable is. And half of neonatal mortality is, something we should be worrying about. Yeah.
Yeah, we have a question in the chat here from Caitlin Escobar. She says, thank you so much for your talk. I am curious how we can leverage results from latent class analyses to inform working definitions of FGR. Are we at a point where we could use the results of multiple LCAs to define FGR cases in our studies, or are we still at a stage of using large data sets to find relevant variables?
Oh, what a good question.
And there's a little more too. Is there a notable risk of bias in this approach?
Oh, I wish she had said more about what bias she was worried about. There's always a risk of bias, that's epidemiology. If nihilism is Graham's middle name, bias is epidemiology's middle name. And I'm not talking about prejudice, I'm talking about just unmeasured factors influencing our data. So is latent, I think what I would like to see is another data set that also tried to use latent variable analysis with a similar combination of imperfect measures in another data set to see if it converges on the same results. And if it did, then we can start thinking about, is there some way to combine these in a way that could be functionally useful for clinical identification? But I need to think more about that. I mean, I think it's a really interesting question. I had never got to asking that myself.
Thank you.
Yeah.
Hey, I was curious, because when you look at the Canadian paper, and I obviously haven't seen it, but I noticed that there was metabolites at the bottom. Are we talking about what type of metabolites were they talking about? And how is this pre-birth, post-birth, or?
That's a great
Yeah.
question. I was gonna ask almost the same one in a different way. When I'm online, I can do screen snips and get through, but I can't
Oh, right.
remember. But I thought your Canadian thing had 4 factoids on it. And the bottom one was, acidosis was one. Is that correct?
Yeah.
4 factoids,
That's
okay.
right.
Are all of those neonatal, or, because I might ask at Crown tutor some perspective measurement rather than.
Right,
neonatal.
so they use Doppler measurements. They
Yeah.
had some Doppler measurements. And I think that their placental, it was a mix of some neonatal and some collected during pregnancy. I think there were some placental markers that they had used that were from maternal blood,
The perspective.
in earlier in pregnancy.
So,
It was acidosis, so it was a pH, it wasn't.
Yeah,
It wasn't the reactions on tap, so it was that pH again, I just think it was fetal blood
In the newborn,
in the newborn,
yeah.
and that would be urine or blood, right?
Blood,
They'll
I
look at
think.
like cord blood acidosis and they'll look, so it's, I think the problem is that it's such a small group, no matter how you define the fetal growth restriction. And the standards of practice is you have to have an indication during gestation to get Doppler measures, which kind of narrows your lens and your window. And then you have to have complications at birth. When you look at acidosis, it's just not, it's not sensitive or specific on, for mortality. And it's not even for what they call, hypoxia ischemic damage. It doesn't. So what I'm saying is, you'll get blood gases, from the cord blood, but in a much smaller fraction, you might have some Doppler waveforms that would be in a high risk situation that has many different confounders. And then in some pictures, you might get placental histopathology, but those require certain indications. So there's no normal reference group in most studies. So it's definitely a jigsaw puzzle where, every parameter that you have is completely imperfect and there is no reference standard to really make sense of it. Because a lot of the technologies are kind of implemented, not in a scientific way. They're just kind of run forward and they're standard of care before we even really know what we're looking at. So I think that, bodes well for thinking of it in different ways, like this group might think about it of what could you measure and could you do? So there's work of like looking at, the metabolites are looking at placental expression or the angiogenesis regulating factors are a story there. But again, it's not a complete story. So I think there's a lot of ground to isolate what you're talking about of what is this undiscovered thing, but it's going to take much like you of that measure small things and piece it together.
But I guess in the talk, I kind of heard it referring to preeclampsia, or they thought is there a relationship to preeclampsia?
Yeah, we think so. Seems like the babies who have the most severe growth restriction have a lot of pathologies.
And then we're going back to this idea of defining it, right? So the idea that, this idea of full health, right, from beginning to end, so pregnancy forward. But if you're gonna, so do you define it in the womb? Do you define it after the womb? What stage would you call it?
They do both, but in the womb, you're relying we're not very good at detecting small babies, even though the technology's been around for a long time. So it's,
Yeah, you talk about like small babies, right? So I had a postdoc in my lab and he was all of baby 4'10", he was very short and his wife was and shorter than him. And their baby went through, because it was a very small baby. And it was like, at the end of the day, they just thought it was a small baby because
they tend to look at the Doppler waveforms, and so more so than the growth percentile during gestation. But even the Dopplers, there's a lot of interpretation there, and there's a lot of measurement misclassification. So
baby would have been born on time, 2 pounds late.
yeah,
So instead of 2 pounds on time, but 2 pounds light. So
even for both preeclampsia and for fetal growth restriction, they basically look for some evidence of some end organ dysfunction, which can be, pick or choose what you wish. That there's one signal, then there's something else, it's severe enough and it looks like some end organ system, but that's basically the best they have. So the maternal fetal medicine will look for like a Doppler abnormality, but few babies will get Doppler because you have to have an indication. And not always is there a pregnancy indication. Some of this is a surprise. So I think that's the issue, is that we keep looking at it in so many different ways that it's not going to fall on us. I think it's going to take some kind of a perspective design to go after the right data, because it's
well, that's what I was.
yeah.
Okay. So one more time, you don't typically it's defined sometimes at birth, sometimes after birth, because growth doesn't happen, or is it?
No, it's at birth.
Oh, it's always at birth.
Yeah, it would be, it's failure to grow after birth is like a different
That's what I thought.
category of problem, yeah.
They have fetal curves and the newborn curves, but for epidemiology, we tend to look at it as in order to be in the numerator, basically you have to be live birth to be at risk for some postnatal disorders, so they'll condition on that. But they have a bunch of different growth curves that are fetal growth curves, and I think those including the Tarka curve that
Right.
came out of but even those, it's there's a lot of error there. It's just very difficult to get a good measure on this. And they'll look at you know, you can look at blood biomarkers, you can get the placenta afterwards, but you know, so far there's no complete story here, and like, so there's some utility to it, but I think that there needs to be more thinking about it in a translational kind of model.
And Jennifer Hutchins' data were valuable because it was, all these tests were consistently done on the whole population, not just on an indicated subgroup that, well, you know, they were worried about. So that's what allowed that latent variable analysis. But that's, you know, that's the only data set I know of that exists like that.
And you said with preeclampsia, the earlier in gestation that the pregnancy delivers, the higher the overlap between preeclampsia and a small baby, to the point where if you go below about 26 weeks, it's 100% overlap. So it's, you know, where you get the highest opportunity to do the research. So the earlier in gestation you go, the more cases you're going to get. The confounders and the multiplicity of a bunch of things going wrong in mom and baby is just, it's amazing. It really clouds what you can look at. So it does require high sample size, but I think epidemiology, like you had said, like it might top out because it's not going to be just a sample. Basically, if you combine all the registers, you probably still wouldn't get a handle on it. You're probably going to need to figure out some creative molecular measures, some kind of expression profiling in the right population to figure this out.
Is there a population that has been identified that's at higher risk? I mean, just from the standpoint of even the Canadian curve, you know, is there?
Yeah, I mean, they do so it's your standard stuff of like all pregnancy complications. It's pretty much like pre-pregnancy obesity. You can, you know, there's interesting stuff with smoking. Smoking sometimes will go small baby, but it'll be protective for like mom's preeclampsia. So there's interesting things that could be teased out of, you know, for an animal model. For, you know, there's probably pay dirt there that people should be thinking of. The, you know, advanced age, you know, there's overlap with different types of placental histopathology patterns, which makes a lot of sense. But even earlier than the placenta is fixed, if you know, a lot of it is the growth problem has happened as the placenta is still forming. It probably is something that's driving the placental problem and the small baby, which are probably related. So it's quite a puzzle, but I think it's worth thinking about because it seems like it should be tractable in a translational model, but you have to think carefully about it, I would guess. It's interesting.
Any other comments from the?
We have time, we may have to finish otherwise. So, I'm sorry.
Oh, you're good. Go ahead.
Okay, yeah, so, we were talking earlier about the Pregenesis group, which is this European multi-lab placentology group, and they are linking really early markers, or trying to, with PE.
Right.
So early placenta, late placenta,
Right.
you know. So they got back to 12, 13 weeks with one of their markers, and that's the time reperfusion starts, because the syncytial trophoblast plug breaks and oxygen floods in really quickly. And you have crown to rump, right? Is that right? At 10 to 12 where it starts, or you can get significant changes in crown to rump in a group, in a small, in a subset at 10 to, or is it in the Canadian paper? Where is that? Where are those data?
The data showing early ultrasound is related to,
Yeah.
there are several ultrasound papers.
Yeah.
They're clinical prospective studies. And I can't remember at what stage the ultrasounds were done.
Pregenesis ended long before the Canadian FGR paper. So,
Yes.
you know, I mean, if we can start bootstrapping our way back, and we can just, the 13-week markers that they came up with, if there's a 10-week FGR
Right.
marker,
Right.
and then we could go back, because we're coming up on chemical pregnancy and implantation loss
Yeah.
markers.
Yeah.
And we
Right.
could start connecting them, which is
Right.
the original goal of Pregenesis, was
Yeah,
to get
that's
the
right.
earliest markers,
No,
which
it-
they didn't
I
succeed.
totally agree.
Yeah, so you need to connect it to certain data and march backwards in time.
Yeah. Yeah.
I'll ask last one of like, we'll carry on later on.
All right.
So you showed your rock curves. You're looking at Newton's index. But when you look at the maximal sensitivity and specificity, the false positive rate is usually above 50%. So do you think there's a way of looking at this in terms of a likelihood ratio positive? So if you maximize modeling
Yeah,
sensitivity at either a fixed rate of false positives, because like trying to get towards a higher positive predictive value.
yeah, right. That's a good point. And I think about that especially in the context of fetal deaths, actually, because it's, you know, the SGA literature is almost all about neonatal deaths. And the problem with understanding fetal growth restriction in fetuses is that if we wait for delivery, I'm giving you a roundabout answer, but I'll get there. So the birth weight of a stillbirth has been affected by the fact the baby died sometime before delivery in most cases. And so it's lost some weight. So that sort of complicates our interpretation of association between size and outcome. But given that problem, it does appear that fetal growth restriction is a much stronger cause of death for fetal death than it is for neonatal death. And so I would love to see a study, especially of early stillbirths, which are, you know, thank God it's rare, but those babies probably have a lot of fetal growth restriction in that category. So I don't know how you find those babies. Take a multi-center consortium to do it, but I think that would be a way to get at that problem you're pushing against, because can we improve our sensitivity by going to some extreme category.
One last quick one for study design people thinking, do you think of the risks of death or mortality? And do you think they're the same risk factors as like developmental morbidities, or do you think they're completely different?
Yeah, no, I think they're linked.
They're linked.
Yeah, so when I was a co-author of one of these papers where we're trying to estimate the prevalence of fetal growth restriction, just not on individual babies, but globally in the population. And we looked at neonatal mortality as an outcome, and then we looked at cerebral palsy as an outcome. And the risk associated with our very indirect measure of fetal growth restriction was about 20-fold for cerebral palsy. So I'm thinking of this as all part of some massive disruption that goes on in the development of the fetus that can cause fetal death, neonatal death, and probably developmental disabilities too. So much interesting stuff.
Continue on. Well, thank you so much.
To be continued.
Yeah,
Thank you.
Thank you.